Hi students, we were talking about the beta error. What is a beta error? Beta error is nothing but do not reject H0 when H0 is false. Okay, H0 is false, we should have rejected. Instead, we do not reject it. So, error is committed. This is known as the beta error. So, probability of committing this beta error is x belongs to omega bar, where omega bar is nothing but the non-rejection region. Actually, H1 is true. Although H1 is true, we are not going to reject it because omega bar is a non-rejection region, and we say they belong to non-rejection region. So 1 minus beta, opposite of that, complement of that, we can say complement of beta is 1 minus beta. That is 1 minus probability of do not reject H0 when H1 is true. What is complement of this? It's nothing but reject H0. H0 is not means H0 is false or H1 is true. Okay, same way. H1 is true, or you can say H0 is false. Other way of telling is, instead of telling H1 is true, we can say H0 is false. H0 is false. What we did? We rejected it. We have taken the correct decision. So 1 minus beta is the correct decision. So what is 1 minus beta? Beta is known as the power of the test. 1 minus beta is the probability of correct decision, also known as, this is known as the power of the test. 1 minus beta is known as the power of the test. Since it indicates the ability or power of the test to recognize correctly that the null hypothesis is false. We recognize it, null hypothesis is false. We are able to recognize it correctly. If the null hypothesis is false, we are able to recognize as it is false. So that ability to recognize it is false, that is known as the power of the test. That ability is known as the power of the test. So previously we talked about the alpha, right? Alpha error, that is what to say, where the rejection, where it is rejection region or not in the rejection region. So that is alpha error. Now we are able, our ability to recognize that null hypothesis is false is known as the power of the test. So we say that statistical test is ideal if the minimizes the probability of both errors. If we are able to minimize both the errors, then we can say it is an ideal test. So when you can maximizing the probability of decision error, that is quite possible. So when we want to minimize the alpha error, then beta error will increase. So we can say it is a seesaw type of thing. So one error, if you try to compress one error, the other error will increase. That is something like a seesaw type of thing. But both the error has to be minimized. When the size of the sample is too big, when you take the population itself, then we can minimize it. When you are doing the error while selecting the sample, right? The sample, wrong selection of sample, then only we are committing the errors. Okay, so we have to fix the sample size. In order to minimize it, we have to fix the sample size. Alpha and beta are also so interrelated that the decrement of one result, if you try to decrease one, the other one will increase. So minimization of both the probabilities type 1 and type 2 errors simultaneously. If you want to minimize type 1 as well as type 2 both simultaneously, you want to minimize these two errors, what we have to do for fixed sample size is not possible. If you take the fixed sample size, we want to minimize both the errors. That is not going to happen. So without increasing the sample size. So we have to increase the sample size. Also, both types of errors will be at 0 level or no error. When it will be no error, if we take the sample, if we take the population itself, because we are committing all this type of error by taking the wrong sample. But if you take the whole population itself, both the errors will be minimized. The size of the sample should be equal to the population size. But it involves huge cost if the population size, if you take the whole of population, too many cost is involved. And it is not possible also. Okay, for example, if you want to test the blood for this malaria patient, no, we have taken only sample. We cannot take the whole blood from the patient and test it. It is not going to happen. So many times, many cases, we are compelled to take the sample. So depending on the problem in hand, we have to choose a type of errors which has to be minimized. So we can say which error has to be minimized. We have to see what problem we are having. So according to the problem, which error, we have to minimize it. We have to take the decision. For this, we'll see one example. Suppose there is a decision making problem. Okay, there is a rule that if we make type 1 error, so there is some problem we are having, decision making problem. Suppose if you commit the type 1 error, we lose 10 rupees, right? If we make type 2 error, we are losing 1000 rupees. So it is better to lose 10 rupees rather than 1000 rupees. So we'll say that I will commit type 1 error but never commit the type 2 error in this particular case. In this case, we try to eliminate type 2 error. So as far as possible, we eliminate the type 2 error. Because if we commit type 2 error, it is more expensive. We'll be losing 1000 rupees. Right? In another situation, suppose a Delhi police arrest a person whom they suspect is a murderer. So police is arresting a person, and that person is they're suspecting that he is a murderer. Okay, Delhi police, what he is doing, he is arresting a person. Why he is arresting? Because police suspects that he is a murderer. Now policeman has to test the hypothesis. So H0, we always take the Madhyama Pada, no? Buddha's Madhyama Pada. That is middle path. Arrested person is innocent. Always we take that arrested person is innocent. Is not a murderer. What is the alternative hypothesis? Arrested person is a murderer. Alternative to that. Actually, his means we are taking H0 as innocent. What is the complement of that? Arrested person is a murderer. So type 1 error, alpha error. That is rejecting H0. Rejecting H0 means when arrested person is innocent, okay, and we say we reject it. Okay, we reject it means we conclude that he is a murderer. Okay, the type 1 error alpha. What is type 1 error? Type 1 error alpha, we have seen already, right? Reject H0. So if you reject H0, that is arrested person is innocent. If you reject it means what is the complement of this? He is a murderer. Police concludes that he is a murderer. So reject H0. When it is true, actually the person has not committed any mistake, but what you have taken the decision as if he has committed the murder. So police has taken the decision that this person has committed the murder. But the true case is he is not a murderer. Okay, so police has committed the type 1 alpha error. Okay, that the suspect's person who is actually an innocent, he is an innocent person, but the police says that he is a murderer, and he is given the punishment or the death sentence. It's a very big punishment, right? Now you go to the type 2 error. Type 2 error is beta error, right? Do not reject H0. Okay, do not reject H0 means we are taking that arrested person is innocent, and we are not rejecting it. So arrested person is innocent. We accept it. So do not reject H0. Actually H1 is true. That is arrested person is a murderer. True cases, he has committed a murder. Police says that he hasn't committed any murder. Okay, so wrong decision is taken by the police. It is known as a type 2 error, beta error. That is when arrested person is truly murderer. Such may he has done murder. Truthfully he has done the murder. But he is released. Although he has committed the crime, he is released. Now, which type of error is more serious in this case? Type 1 error is more serious than type 2 error. Right? An innocent person should not be arrested. Means innocent person should not be given any punishment because he hasn't done any murder. But you cannot give any punishment to the innocent person. So committing type 1 error in this case is more serious because you are giving punishment to innocent person who hasn't done any murder. He is very innocent, and you have given the wrong decision, taken the wrong decision that he has committed the murder, and all the death sentence and everything is given to all the related punishment is given to that particular person. So type 1 error is more serious in this case. You cannot type 2 error is not that much serious. That is a person who has committed the murder, and because of the wrong decision that he has not committed the murder, he is released. Okay, that person can escape, but we cannot never and ever innocent person should be punished. So type 1 error is more serious than the type 2 error in this case. That is because a murderer may be arrested, punished later on. So later on also he may be punished. But when you punish the innocent person, you cannot take the punishment back, right? So if the person has committed murder and you released him, later on also he can be punished. Therefore, such error you can say that type 1 error should be minimized. Alpha error should be minimized in this case. So which type of error we have to minimize it? We have to take decision according to the problem we are having. So in the previous case of murder, alpha error has to be minimized. We should police should ensure that we should never commit the alpha error. So general procedure of testing the hypothesis. Now we go to the second topic, that is general procedure of testing the hypothesis. First is, suppose it is found that average weight of potato was 50 grams. What is the average weight of potato? It is 50 grams and the standard deviation was 5.1 gram nearly 5 years ago. It was 5.1 gram nearly 5 years ago. What are the data given here is average weight of potato 50 grams and standard deviation is 5.1 grams. Then this we found many years, 5 years before. We want to test that due to advancement in the agricultural technology. Now 5 years before only tested. No, now today agricultural technology has advanced. The average weight of potato has been increased because we have used a lot of in the field we have used so many fertilizers and so many things. Because of that, potato yield has increased. So to test this, a random sample of 50 potatoes is taken. Calculate the sample mean X, okay, 52 grams. Describe the procedure to carry out this test. So that is what is asked. Question is asked. So whatever is given data, we will write it down. Okay, what is given in this question, we will write it down the data. So in the question, what is given is mu naught. Okay, mu naught is given as 50 grams. And then population standard deviation sigma equal to 5.1 grams. And sample size equal to n equal to 50. Okay, sample mean equal to x equal to 52. Okay, grams. These are all given. Here mu naught is given 50 grams. That is population mean is given as 50 gram. And population standard deviation is 5.1 grams. Sample size is, we have taken 50 potatoes, no, n equal to 50. Sample mean x equal to 52 grams. So to carry out the above test, we have to follow the following steps. What are the following steps? We have to take the step 1. What is step 1? First of all, we have to set up the null and alternative hypothesis. Set up null and alternative hypothesis. Right? Here we want to test the average weight of potato is increased. What we want to test? Here we want to test that the average weight of potato is increased. So we claim that average weight of potato has increased. What is our claim? Average weight of potato has increased. Okay, that is mu is greater than 50 and its complement, whenever you say mu is greater than 50, its complement will be mu is lesser than or equal to 50. Okay. since the now we'll